Okay, and number 7 on the review, it says an auto mechanic finds that the useful life of a spark plug in a car is approximately normally distributed with a mean of 12 months. So our mean is given to us. It's approximately normally distributed, so we can set up our curve right away. The standard deviation is 4.3. If a spark plug is randomly selected, find the probability that it will last less than 8 months. So 8 falls to the left of 12 on the number line. We're looking for less than that. We're going to convert this to a standard score. We do not have to change 8 by 0.5 because the mean and the standard deviation were given to us. Okay, so 8 minus 12 divided by 4.3 gives us negative 0.93 for our standard score. Then our probability will come from normal CDF, negative 10, to negative 0.93. We got 0.176185552. So to 4 decimal places, that's 0.1762. Numbers 8 and 9 are both very similar in the fact that we're looking for our standard deviation. In number 8, it says that normal distribution has a mean of 36. However, it is known that 35% of the area lies to the left of 25. So we have 35% to the left of 25. To find our standard deviation, we're going to use this equation. Our x will be 25, our mean will be 36. Z, though, is not 35%. We actually have to find z by using the inverse norm. We enter in the area at the bottom of the curve. Okay, so using our inverse norm, with 35% at the bottom of the curve, we get 0.3853204.726. Remember, we round it to 2 decimal places, so we get negative 0.39. Okay, then we go through and we solve this equation for our standard deviation. We get 28.205-ish. Okay, the next one says the weight of a member of the Stags football team is approximately normally distributed with 174 pounds. It is known that 22% of members are more than 180 pounds. Find the standard deviation. So this one again is extremely similar to number 9. The issue here is that we are given the area at the top of the curve. So when we use the inverse norm, we can do one of two things. We can enter in 22%, but it's going to give us a negative z-score for the bottom 22%. We have the top 22%, so all we would need to do is switch the sign. Or, to find z, we can enter in the inverse norm, and then the area at the bottom of the curve, which would be 1 minus the 22%. Either way, we'll end up with the same z-score, which comes out to 0.77. So we're going to get 0.77 times our standard deviation equals 6. Then we're going to divide both sides by 0.77. And we're going to end up with a standard deviation of 7.792207792. We round our standard deviation to about 3 decimal places. Okay. Number 10. An airline company finds that 97% of people who make reservations actually keep them. The airline company accepts reservations for 500 people, so that looks like a sample. What is the probability that exactly 400 people show up? Exactly, again, means equals. So we're looking at the probability they show up, which would be 97%. So here's the information that we're looking at. So we're not given our mean to figure out what goes in the center, because how do I know where to put 400 inside of this curve? So we have to calculate the mean and also our standard deviation. So our mean will come from 500 times our 97%, and we get a mean of 485. So that's the number in the middle of the curve. So now I know 400 is over at the left. Then we calculate our standard deviation, n times p times q. N is 500, p is 0.97, q has to be 3%, because remember, p plus q has to equal 1. And we end up with a standard deviation of 3.814. So we calculated our mean and we calculated our standard deviation, which means we have to change x by 0.5. Well, it's an equals. We can't just use 400. Whenever we have an equals in a binomial probability, we change x by 0.5 in both directions. So we're going to change this to 300. We're going to change 399.5 and 400.5 to z-scores. So this would be x minus the mean divided by our standard deviation. Then we have another x minus the mean divided by our standard deviation. Okay, so we're going to change both of these into standard scores. What you're going to recognize is that we actually get a pretty extreme z-score. So for the first one, we get negative 22.42. Okay, again, remember we're rounding our z-score to 2 decimal places. For 400.5, we get negative 22.16. So you should recognize that these are very extreme values and it's extremely unlikely for this to happen, so our probability would be 0. If you are going to enter this into the calculator because you don't recognize that the probability would be 0, this is the way that we would enter it. What's going to happen when you enter this is you are going to get 0.